It began as a whisper, a faint signal travelling across billions of miles of cold, empty space. This whisper came from a traveller, one of humanity's most ambitious, most resilient explorers. Its name is Voyager 2. Launched long ago in a time of different music and different dreams, it has journeyed farther than we could have imagined. It was sent to see our neighbours, to take pictures of the giant planets, Jupiter with its unending storm, Saturn with its rings of ice and dust, Uranus and Neptune, the blue-green mysteries at the far end of the neighbourhood. Voyager 2 did all of this and more. It gave us our first close look at these worlds. But its journey did not end there, it just kept going. Think about that for a moment. A machine built by human hands has been flying for nearly 50 years, through the dark, through the silence. It carries with it a message, a golden record with the sounds and sights of our world. To understand this story, we must first understand where it is taking place. Where is Voyager 2 right now on this day, August 12, 2025? It is a place so far away that the numbers begin to lose their meaning. It is more than 13 billion miles from Earth. Let that sink in. If you were to travel that distance in a car, it would take you tens of thousands of years. Even light, the fastest thing in the universe, takes over 20 hours to make the journey from Voyager 2 back to us. When we receive a message from the probe, we are hearing news that is almost a day old. It is a conversation with a significant delay. From Voyager 2's perspective, our sun is no longer a brilliant, life-giving star. It is just another point of light. The brightest star in its sky, yes, but still just a star. The planets of our solar system, including our own Earth, are completely invisible, lost in the glare of that distant sun. So what is this edge of the solar system? It is not a solid wall or a line you can see. It is an invisible bubble, a vast magnetic bubble blown by our sun. Imagine the sun is a giant fan, constantly blowing a wind in all directions. This wind is not made of air, but of charged particles, protons and electrons. It is called the solar wind. This wind travels out past all the planets, creating a protective bubble around our entire solar system. Scientists call this bubble the heliosphere. Now imagine another wind. A wind that blows not from our sun, but from all the other stars in the galaxy. This is the interstellar wind. Out in the vastness of space, these two winds meet. The place where these two winds collide is the edge of our solar system. Here is where our story takes its turn. As Voyager 2 approached the edge of the heliosphere, its instruments were on high alert. Scientists on Earth were watching the data closely. They were waiting for the moment the probe would cross into interstellar space. But then, something impossible happened. Just before it broke through to the other side, Voyager 2 hit a wall. Not a physical wall, of course, but a wall of energy. A wall of plasma. The instruments on the probe detected a sudden dramatic increase in the density and temperature of the plasma, the superheated gas that makes up the solar wind. It was as if the boundary was thicker and stronger than anyone had anticipated. This was not the smooth, leaky border we had imagined. It was a formidable barrier. This wall was a complete surprise. Voyager 1, when it crossed the Heliopause 6 years earlier, did not detect such a sharp, dense boundary. But the surprises did not end with the wall of plasma. As Voyager 2 punched through this unexpected barrier and entered interstellar space, it detected something else: shockwaves. Not just one, but several. These were powerful disturbances, ripples in space that had travelled out from our sun. What it saw was astonishing. The shockwave from our sun struck the heliopause and did not just fade away, it reverberated, it bounced. It caused the boundary itself to ring like a bell. Some of the energy even seemed to leak back into our solar system. Even more remarkably, this event triggered another shockwave on the other side, in interstellar space, a kind of cosmic echo. This was the first time we had ever been able to measure such an interaction from both sides of the boundary. We had a witness in interstellar space watching a solar event unfold. This observation is incredibly important. It changes our understanding of how our solar system interacts with the rest of the galaxy. Back on Earth, the teams of scientists who have dedicated their lives to the Voyager mission were in awe. The story of Voyager 2 is filled with fascinating details. Did you know that its computers have less memory than the key fob you use to unlock your car? Yet, with that tiny amount of computing power, it has navigated the solar system and is exploring the space between the stars. Another interesting fact is about its golden record. Carl Sagan and a committee assembled a time capsule of sounds and images from Earth. The probe's power comes from a device called a radioisotope thermoelectric generator, or RTG. It uses the heat from the natural decay of plutonium-238 to generate electricity. Even communicating with Voyager 2 is a challenge of cosmic proportions. The signals we receive are incredibly faint. By the time they reach Earth, they have a power of less than a billionth of a watt. It is like trying to hear a single snowflake land from miles away. We need our largest radio antennas, the massive dishes of the Deep Space Network, to listen in. The story of Voyager 2 and its impossible encounter is not just a story about plasma and shockwaves. It is a story about us. It is about our unyielding curiosity and our relentless drive to explore. We send probes like Voyager out into the darkness because we have a fundamental need to know what is over the next hill. The Voyager probes were built and launched by one generation. They were guided past the outer planets by the next. And today, a new generation of scientists is interpreting their data from interstellar space. There will come a day, perhaps in the next decade, when Voyager 2's power will finally fade. Its whisper will fall silent. It will no longer be able to tell us about its journey, but its voyage will not be over. It will continue to drift through the Milky Way galaxy for millions of years, a silent ambassador of Earth, a ghost ship carrying our music and our greetings, and it will have left us with a treasure trove of data. Decades of discoveries that will continue to teach us about our place in the universe long after its last signal has been received. So we should look up at the night sky with a sense of hope, because out there, in the unfathomable distance, our messengers are flying. They are pushing the boundaries of what is known. They are reminding us that we live in a universe of endless possibility, a universe that is still revealing its secrets to us, one faint whisper at a time. The journey of discovery is far from over. In fact, in the grand scheme of things, it has only just begun, and the path ahead is illuminated by the faint receding light of pioneers like Voyager 2. Please like and subscribe to Cosmic Discover.